Hello class, this is a video tutorial on the index laws part 3. In this video we'll be looking at the multiplication of indices. Indices of a single term group multiply with the indices of each component of the term. I know there's a lot in there, but I'll specify more what it means. If you have a group with only one term in the entire thing. So an example of something that's not one term would be m to the power of a plus n to the power of b to the power of c. This has two terms inside of the group. So this law that I'm about to show you does not apply to something like this. There needs to only be one term in this entire group. If all of this one term has a power, that power multiplies to each of the terms, to each of the indices of the components. So it becomes a times c, ac, b times c, bc. It works the exact same way if you have a fraction like so. It still becomes a times c and b times c. So this, like I've shown you earlier, this shouldn't be confused with something like this. So if you have these as powers of 1, these do not multiply to become m to the power of c plus n to the power of c. This is very wrong. Now the most common error, one of the very common errors that I've seen is something like this. We have x plus y all squared becomes x squared plus y squared. This is also incorrect. So let's just use what we've just learned then to these ones here. So let's evaluate the following. We have two components in this one term. This will become, there's a 1 next to that 1 power for the 2. So this will become 1 to the power of 1 times 5 is just 5. X to the power of 1 times 5 is also 5. 2 to the power of 5, I believe, is 32. You can correct me with your calculator if you have that, but I'm pretty sure it's 32. So this becomes 32x to the power of 5. Looking very carefully how there's no addition or subtraction in here. It's all one big term. So with this, we have 3 to the power of 1. That 1 is going to multiply with the 3. So it becomes 3 to the power of 3. Even with negative indices, it'll be negative 2 times 3. So it'll become negative 6. B, 4 to the power of 3 is 12. 3 cubed is 27. The a is now in the denominator. So a to the power of 6. And then b remains in the numerator. Let's just clean this up a little bit. 27 b to the power of 12 all over a to the power of 6. Two more examples. As we saw earlier, even with fractions, the powers still multiply with the current powers in the term. So this becomes 2 times 3, so x to the power of 6, 3 times 3, x to the power of, y to the power of 9. And there we have it. One last example here. The negative 3 applies to everything. There's actually a little idea that you can use here. Rather than apply the entire 3, apply just the negative for now. Meaning it'll become 3y squared all over 2x to the power of negative 1 to the power of positive 3. So we applied the negative to all the terms, and because negative indices, force them to transfer from numerator to denominator, you can see that I flipped everything from numerator to denominator and vice versa. And now we can apply the 3. So 3 to the power of 1 times 3, that becomes 3 cubed again. Y squared, so that's 2 times 3, that becomes y to the power of 6, all over, 2 to the power of 3, and x to the power of negative 3. Evaluating all of this, 3 cubed is 27. Notice how the x is a negative, so it has to be moved into the numerator. This becomes x to the power of 3, y to the power of 6, all over 2 to the power of 3 is now 8. And we've already moved the x cubed to the numerator, so this here is our final answer. So I hope that gave you an insight into to the multiplication of indices and how it's also applied alongside negative indices. Hope to see you in the next video. Best of luck.